Hello, welcome to Video 3D. This video is called Power Rule Practice. Pretty much, we only have a rule for two things so far. How to take the derivative of a constant. You see that rule here. If our function is a constant, the derivative is 0. And we know how to take derivatives of powers of x. So if f of x equals x to the nth power, n could be a whole number, an integer, or a rational number, then f prime of x is n times x to the 1 less power, to the n minus 1. Okay, let's go through this and practice this. Here are our first 4 examples. So it says differentiate each function with respect to x. Okay, so we have the first one, y equals 10x to the 4th. The exponent is 4, and that's the value of n. So dy dx, which is the derivative of this function, would equal 10 times the derivative of x to the 4th. Well, according to the power rule, we multiply in front by the exponent. Then it's x to the 1 less power. 4 minus 1 is 3. So I get 4x to the 3rd as the derivative of x to the 4th. Then we may have to multiply to simplify. So 10 times 4 is 40. So we get 40x to the 3rd. Okay, let's try this one. So we can call the derivative dy dx, or sometimes we call it y prime. We have a lot of different notations for the derivative. Y prime is kind of easy. So it's 5 times the derivative of x cubed. Derivative of x to the 3rd would be 3x squared. And if I multiply the 5 times the 13 and simplify a little bit, I get 15x squared. Notice that the exponent multiplies the coefficient. We have 5 times 3, the coefficient times the exponent. Alright, here we can think of the exponent here as 1. We can think of this as 1 times 9 times x to the 0. So, or 9 times the derivative of x, which is 1. That's the same as x to the 0. So this is just 9. So I'm thinking, instead of thinking of x to the 0, it's probably better to remember that the derivative of x is just 1. Okay. Here we have a constant, 5. So that's a horizontal line. Slope is 0 everywhere. So the derivative of this is 0. So we can say f prime of x. This time we had function notation, so I'm using f prime. I could also use df dx. So another notation for the derivative is just 0. Okay, let's try something a little bit more advanced here. Let's try with negative exponents. This rule works for negative exponents also. So here, f prime of x, the derivative, is negative 2 times the derivative of x to the minus 3. So it'd be minus 3x. Then we gotta think, we gotta subtract 1 from the exponent. Negative 3 minus 1 is negative 4. So altogether, negative 2 times negative 3 is 6, x to the negative 4. And normally we rewrite this with positive exponents. This would be 6 over x to the positive 4. Okay, this one. Alright, I'm going to try a little bit shorter method. Instead of writing 5 times the derivative of x to the negative 4, I'm going to kind of take a shortcut here. I'm just going to multiply the coefficient and the exponent right away. Negative 4 times 5 is negative 20. We get x to the 1 less power. That would be negative 5. And then we're going to rewrite. So this would be negative 20 over x to the positive 5. Same thing here. Multiply the exponent times the coefficient. So instead of writing that out all the time, let's just do that step first. Negative 2 times 10 is negative 20. Then we subtract 1 from the exponent, we get negative 3. So it'd be negative 20 over x to the positive 3. Okay. Same thing here. Negative 1 times 9 is negative 9. We're going to subtract 1 from the exponent, so that'd be negative 2. So this is y prime we're finding. And that would be, let me see, negative 9 over x to the positive 2 if we rewrote it. No problem. Alright, the next complication that can occur is if they're radicals. So we're going to re-express this as a power of x. So I'm not taking the derivative yet. I'm just rewriting this into a form we can use. So this is negative 3. the fifth root of x is the same as x to the 1/5 power. Then we can do the same thing. Multiply the exponent times the coefficient. This time I'll go back to writing it out though. So it'd be -3. This would be y prime now. I'm taking the derivative. The derivative of x to the 1/5 would be 1/5 x to the, we gotta subtract 1 from the exponent. 1/5 minus 1 would be -4/5. Okay, so I get -3/5 x to the -4/5. This is kind of horrible because not only do I have a fraction exponent, it's negative. So I'm going to write this as -3 over 5x to the +4/5. Okay, that helped a little bit. I'm going to write this as a radical. It's x to the 4th power and the 5th root of that. So this is -3 over 5, the 5th root of x to the 4th. That's pretty tricky, but we went over that in class. So x to the 4/5, the 5 is the root, the 4 is the power of x. All right, let's try this one. Let's rewrite it. X, the cube root of x squared. That's the same as x squared to the 1/3, which is x to the 2/3. All right, and we have 4 times that. So 4 times that and 4 times that. Now I'll take the kind of the shortcut. 2/3 times 4 is 8/3. So I'm finding y prime. And then x to the 1 less power, x to the -1/3. So this would be 8 over 3x to the +1/3. That's the cube root though. So it's 8 over 3 cube root of x. Wow. Okay. Let's try this one. So rewrite. So this would be 4x to the 1/3. So it'd be 1/3 times 4. That'd be y prime. So that's 4/3. X, subtract 1 from the exponent. 1/3 minus 1 is -2/3. Okay, I'm going to see if I can rewrite this without so many steps. 4 is going to go in the numerator. 3 is going to go in the denominator. When I move this to the denominator, it's x to the +2/3 would be x squared and the cube root of that. Like that. That's x to the -2/3. It's x to the +2/3 in the denominator, and rewrite it in radical form like that. Okay, we'll get the hang of this. So again, rewrite. This is 4x to the 1/4. So y prime, do the exponent times the coefficient. 1/4 times 4 is 1. X, subtract 1 from the exponent, is -3/4. Okay, this is going to go in the denominator. It's x cubed to the 1/4 power, so we could write this as 1 over the 4th root of x cubed. Okay, so when I move in the denominator, it becomes x to the +3/4, which is the 4th root of x cubed. Okay, now we're getting there. So now we have a couple additional tools here. When we have a sum of two functions and we're taking the derivative, we can just take the derivative of each and add them. Same for differences. So we know how to handle sum and differences of functions. So that's what we have here. We have a sum of functions here, or terms here. We can just take the derivative of each one of them and add them up. So y prime would be -3 times the derivative of x to the 4th. I'm kind of doing it the long way here again, right? Plus the derivative of x cubed would be 3x squared. Plus 2 times the derivative of x squared would be 2x. Then I just simplify. This is -12x cubed plus 3x squared plus 4x. Done. Now, I'm going to use the shortcut this time. So, instead of writing this out as -3 times the derivative of x to the 4th, I'm just going to multiply the exponent times the coefficient, because that's what we're kind of doing anyway. 3 times 4 is 12. X to the 1 less power would be x squared. Plus 2 times 4 is 8. X to the 1 less power would be x to the 1. Plus 3x. It'd be 3 times the derivative of x, which is 1, which would be plus 3. Done. Okay. Let's try these. So, same thing. These have some negative exponents and square roots as exponents. So, let's muscle through it. So, we have y prime. I'm going to kind of use the shortcut I've been using. Negative 4 times 2 is negative 8. X to the 1 less power. Plus, negative 5 times 5 is negative 25. 1 less power would be negative 6. I'm going to rewrite. That'd be negative 8 over x to the 5th minus 25 over x to the 6th. Okay, let's try this one. 2 times 4 is 8, so we get y prime equals 8. X to the 1st. Oh, I should have rewritten this, but I still can. This is 2 x to the 1/4. So plus 1/4 times 2 is a half. Subtract 1 from the exponent, we get negative 3/4. Alright, this is beautiful. The second term kind of stinks though, so I'm going to rewrite it. 1 will be in the numerator, 2 will be in the denominator. I have x to the 3/4 in the denominator. That's the 4th root of x cubed. Alright, I got one last slide here, a couple examples. So just to remind us about this, is kind of our main goal. We're taking derivatives to find the slope of the tangent line, or even equation of the tangent line at a given point. So it says for each problem, find the tangent, the equation of the tangent line to the function at the given point. Your answer should be in slope-intercept form. I don't know if we'll leave it in that form, but we'll find the equation. So here we go. First, we need the derivative, because we need the slope of the function at the point. So here we go. Y prime equals 2 times 2 is 4. X to the 1st, which is just x, plus the derivative of 8x is 8 times the derivative of x, which is 1. We want this at x equals negative 1. That's what this vertical bar means. It means evaluated at negative 1. Okay, so at negative 1, this would be 4 times negative 1 plus 8, which is 4. That's our slope. So we know the slope is 4. We want to go through the point negative 1, negative 1. So we can use point slope form. So we say y minus y1 equals m x minus x1. So we get y minus a negative 1, which is plus 1, equals 4 x minus x1, which is the same as x plus 1. We'll leave it at that. We could solve for y if we felt like it. Alright, we've done a ton of examples. Here's the very last one. So this one, the coefficient is negative 1/2. I can think of this as negative 1/2 x squared plus x plus 5/2. So the derivative would be 2 times that, which would be minus 1, x to the 1 last power, plus the derivative of x, which is 1, derivative of 5/2 is 0. Okay, so y prime at the point we're interested in, where x equals negative 2, will be negative 1 times negative 2 plus 1, which is 3. And that's the value of m. So let's find the equation of the line with slope 3 at that point. So y minus y1 would be y plus 3/2 equals slope, which is 3, times x minus x1 would be x plus 2. Wow. Gotta be honest, I'm tired. That was a marathon of calculus. Well, now it's your turn. So I want you to find the derivative of these 10 functions. This actually won't take you long. The first 8 are just applying the power rule. The first 4 have integer or whole number coefficients. 5 and 6 have negative exponents, so watch out for those. Then 7 and 8, they're radicals. So you're going to change those to powers of x with a rational exponent. All right, and then the last 2, a couple polynomials for you to differentiate. All right, put those in your journal. We'll see you next time.